Hello students, today in our 11th standard physics class we are studying the laws of motion. This is the third unit of the 11th standard physics syllabus. Students, today we are going to see the session number 5, and in this session the important topics which we are going to learn are friction and the two types of friction, static friction and kinetic friction. Then let's see push or pull, which is easier. Let's move to the subject now.
Friction, the force which always opposes the relative motion between an object and the surface where it is placed, is called frictional force. See, if the force is applied is increased, the object moves after certain limit. So there is a limit for each and every frictional force, because if the force is increased, then it cannot be applied between the object and the surface. Due to this, the relative motion between the surface and the object is the main thing we have to count. So let's see what do you mean by this relative motion. Relative motion, when a force parallel to the surface is applied on the object, the force tries to move the object with respect to the surface, like the cars or bike or a van or something moves in the road with respect to the surface of the road. If you have a polished surface, then the friction is less, so the movement is fast. If you have a concrete or some other surface, hard surface, then the frictional force is very high. So the usage of energy is very high in the surfaces other than the smooth. See, the force tries to move the object with respect to the surface. This relative motion is opposed by the surface by exerting a frictional force on the object in a direction opposite to the applied force. Actually, the applied force is towards one direction, the frictional force is towards the ground. So there is a difference between these two forces. Let me give an example. See, imagine you are traveling in a train and the train is moving at a speed of 100 km per hour. Then your speed according to another passenger sitting on that train is 0, because he is also traveling in a 100 km speed. Then according to him you are not moving, but if someone observes you from the outside the train, that means the person inside a train is you, and imagine a person outside the train is watching you standing on the ground. According to him you are moving with 100 km per hour as you are on the train, and the train is moving with 100 km per hour according to that person. And if you see from your side, that means you are inside the train and you are seeing the person who is in the platform, he is also moving apart from you with the same speed of the train. Okay, this is meant by for the relative motion. Let me give another important information. The law of physics which apply when you are at rest on the earth also apply when you are in any reference frame which is moving at a constant velocity with respect to the earth, is known as relative motion. There are two types of frictions, namely static friction and kinetic friction. Now let's see the static friction. This is the symbol of static friction. Static friction is the force which opposes the initiation of a motion of an object on the surface. Okay, so it opposes the initiation of the motion of an object from the surface. When the object is at rest on the surface, only two forces act on it. They are downward gravitational force and upward normal force. Imagine a car is at rest in a station. Okay. The resultant of these two forces on the object is zero. As a result, the object is at rest. See, if some external forces, that means if external, is applied on the object which is parallel to the surface on which the object is at rest, the surface exerts exactly an equal and opposite force on the object to resist its motion and tries to keep the object at rest. Some of you have PUBG or some other online games habit. It's also a frictional force. Okay, it stops you to move to the lesson video. Like this, it's also a object which is opposing the original force. Now, this force implies that the external force and frictional force are exactly equal and opposite. Therefore, no motion parallel to the surface takes place. But if the external force is increased after a particular limit, the surface cannot provide sufficient opposing frictional force to balance the external force on the object. Then the object starts to slide. See, experimentally, it is found that the magnitude of static frictional force Fs satisfies the following empirical relation: 0, which is less than or equal to Fs, which is less than or equal to mu s into n. Here mu s is the coefficient of static friction and n is the normal force exerted by the surface on the body. See, the mu s, that means the coefficient of static friction, it depends on the nature of the surface in contact. That's why I explained you earlier about the road surface. If it is a glass surface, then the friction force is totally nil. If it is a concrete or other surface, then the frictional force will be there. And as you know, N is the normal force exerted by the surface on the body. Sometimes it is equal to the M into G, that means the gravitational force. But it need to be equal to mg always, because the body is lying on the earth surface. The above equation 1 implies that the force of static friction can take any value from 0 to mu s n. In this picture you can see it is easier to move, okay, because the friction, there is a small friction and the force is applied towards that body m1. Here n is equal to m1 into g. Here it is harder to move because there are two masses m1 and m2. The force is not that much sufficient to move against the frictional force. Here n1 is equal to m1 into g plus m2 into g. That's why it's harder to move. Next one, kinetic friction. This is the symbol. If if external force acting on the object is greater than the maximum static friction, the object begins to slide. When an object slides, the surface exerts a frictional force called kinetic friction, which is also called as sliding friction or dynamic friction. And experimentally, it was found that the magnitude of kinetic friction satisfies the relation Fk is equal to mu k into n. Here you can see the velocity and the external force is applied here, and it moves against the frictional force, where mu k is the coefficient of kinetic friction and n is the normal force exerted by the surface on the object. Here, to move an object at constant velocity, we must apply a force which is equal to in magnitude and opposite in direction of the kinetic friction. Okay, so to move an object with a constant velocity, if you want to ride a bike from Tiruchendur to Thoothukudi or Tirunelveli to Chennai, if you want to ride with a constant velocity, then you have to apply a force which is equal in magnitude and it has to be opposite in direction of kinetic friction. So finally we get mu s is less than mu k. See, this is the external force, it's opposite direction the frictional force, right? And this relation mu s is less than mu k implies that starting of a motion is more difficult than maintaining it. Sometimes our bike and car need a initial triggering object. Okay, most of the time we used to feel with the starting trouble with our vehicles. That's all because of this frictional force. Let's see what are the salient features of static and kinetic friction. Very important question, students. A 5-mark question. Static friction, it opposes the starting of a motion. Kinetic friction opposes the relative motion of the object with respect to the surface. Here, for kinetic friction, the surface is very important. That's why we used to have a regular checkup in our tires. Static friction is independent of surface of contact. Kinetic friction is also independent of surface of contact. Mu s depends on the nature of the material in mutual contact. That means the tire and the ground. Mu k, that means the kinetic friction, depends on the nature of the material and temperature on the surface. It's very hard to move in a rainy day than in a hot summer. Static friction depends on the magnitude of applied force, and this kinetic friction is independent of magnitude of applied force. See, static friction can take values from 0 to mu s n, but in kinetic friction it can never be 0 and always equal to mu k n, whatever be the speed, which is less than 10 into 10 meter per second. Fs max is greater than Fk in static friction, and it is less than maximal value of static friction in kinetic friction. Mu s is greater than mu k in static friction, while coefficient of kinetic friction is less than the coefficient of static friction. Now let's see, to move an object, which is easier, push or pull. Let's define this. When a body is pushed at an arbitrary angle theta, the applied force F can be resolved into two components. One is F sin theta, and which is parallel to the surface, and F cos theta, which is perpendicular to the surface. So there are two equal components. One is F sin theta and F cos theta. Actually, we are moving the body against the frictional force. So the total downward force acting on the body is mg plus F cos theta. It implies that the normal force acting on the body increases. Since there is no acceleration along the vertical direction, the normal force N is equal to N push is equal to mg in plus F cos theta. Let us take this as equation number 1. See, this is F sin theta and F cos theta. It is the upward force in a vertical direction. Here the angle is theta. This is a free body diagram. As a result, the maximal static friction also increases and is equal to Fs max is equal to mu s n into n push, or which is equal to mu s mg plus F cos theta. The above equation shows that a greater force is needed to be applied to push. When an object is pulled at an angle theta, the applied force is resolved into two components. The total downward force acting on the object is N pull is equal to mg minus F cos theta. The equation 3 shows that the normal force is less than N push. From equation 1 and 3, it is easier to pull an object than to push make it move. So finally we come to the conclusion, it is easier to pull an object than to push to make it move. Thank you students, thank you for your patience. Study well.